Hi, my name's Caitlin Waltman, and my science share project is on synesthesia. I will go into more depth on what exactly this is in the next few slides, but a general overview of what it is a merging of senses where you experience two unrelated senses at once. Synesthesia's Greek roots actually mean to perceive together. Synesthesia comes in many forms and variations. These can include audio-tactile, number form, music to color, which is often referred to as colored hearing or seeing music, and grapheme color, which is the most common form. Grapheme color is probably what most people think of when they hear the word synesthesia. This form of synesthesia is when people consistently experience a color when they hear, view, or even just think about letters, words, and numbers. For example, someone might see green every time they see the letter B, or to them, the number 3 might be red. The key word here is consistently. Many people might have their own unique color to word or number association, but that does not necessarily mean that they have synesthesia. So how does synesthesia work? Scientists at the Center for Brain and Cognition at the University of California took two synesthetic people who saw a color every time they saw a specific number or letter and did a few tests with that. The first test was just to confirm that this was a real case of synesthesia, so it focused on making sure that there was consistency between their color and number associations over time. The scientists would put a target grapheme, which would just be a letter or number, on a screen in front of the subject. They would gradually move it outwards in one direction. The subjects were then asked at what point they no longer saw color. The first subject stopped seeing color when the grapheme reached about 11 degrees away, while the second subject stopped seeing color when the grapheme reached 11 degrees to the left of his visual field. Because of this, we can assume that synesthesia is not caused by memory or metaphor, because if it was, why did the subject stop seeing a color at a certain distance, even when it was still fully visible? This led the researchers to believe that synesthesia is caused by cross-wiring between adjacent brain maps. Because synesthesia has also been shown to run in families, it is most likely a mutation that causes a rise of neural connections between these adjacent brain maps. This mutation causes the neural connectors between perception centers to be closer together than the average person. When someone with synesthesia is trying to process information, their brain ends up routing this information through other unrelated senses, which causes multiple senses to be experienced at once, hence why someone could do something like listen to music while simultaneously seeing what color that music would be. Before we dive a little bit deeper into synesthesia, I wanted to mention how synesthesia can be used in art, because I think that is really interesting. Many artists have been able to use their synesthesia to create amazing works of art. Most notably would be Vincent van Gogh. During his lifetime, he often talked about the associations he had between music and color, which led people to believe that he did have synesthesia. When I first heard about synesthesia, I'll admit I was a bit skeptical. What if these people were just extra creative and conditioned themselves to associate certain colors with words? Is there any way to really prove that this exists? Plus, the idea of it sounds interesting and somewhat appealing. You might be wondering if there was a way you could develop this. Luckily, researchers at the University of Amsterdam completed a study called Training Synesthetic Letter-Color Associations by Reading in Color, and have experimented with this idea of conditioning, so we actually can get an answer to that question. Researchers wanted to find out if these synesthetic associations between colors and letters specifically could be learned by someone without synesthesia just by reading in color. To measure the strength of synesthesia, you can use a modified version of the Stroop paradigm. This paradigm is when we struggle to name a physical color when it is used to spell the name of a different color. For the modified Stroop test, they used 4 high-frequency letters, A, E, N, and R, and paired them with 4 high-frequency colors, red, orange, green, and blue. Participants would then read special text where the words were printed with these letter and color pairings. Now on to the results. Figure A shows reaction time between the congruent and incongruent stimuli. In the pre-trials, participants were consistently better at reacting to congruently colored letters. However, after reading the text printed with the modified Stroop test, the opposite happens. Now participants were better at reacting to incongruently colored letters. This graph shows an example of the significant difference between the Stroop effect pre- and post-reading, and a strong association between the two. While this experiment shows that it is possible for someone to develop a letter-color association just by reading in color, similar to the grapheme color synesthesia, they would not be considered a synesthete. In order to be considered someone who actually has synesthesia, there must be consistency between the associations over time, with the beginning in early childhood. So unfortunately, unless you were born with the necessary brain mapping, you cannot teach yourself to make synesthesia art like Vincent van Gogh. Now you might be wondering if we can actually test for synesthesia to prove that someone has it. We can test for synesthesia, and the University of Edinburgh found a good way to do this based on consistency between associations. The subjects getting tested will be given the definition of synesthesia and also provided some examples of it. They are then given a survey to compare triggers and experiences. Triggers are the stimuli. These can include letters, words, names, music, taste, colors, emotions, and more. Experiences are the reaction to the stimuli. Experiences can include, but are not limited to, colors, shapes, pattern, music, taste, and smell. If a participant believed that they might have music to color synesthesia, a line between music as a trigger and color as an experience would be drawn. Participants were also asked if their experience was a result of drug use, since some drugs can cause experiences of synesthesia. But this would not necessarily mean that the participant actually has it, so these participants were removed. It's important to note that in this experiment, no sex bias was shown, going against previous beliefs that females were more likely to have synesthesia. Reason for this false belief could be due to the levels of self-report, where women are just more likely to take health-related surveys. To then find the actual cases of synesthesia, participants who originally marked that they did have associations between triggers and experiences were asked to record these specific associations and were later tested on them after a few months. If participants did not consistently report the same triggers and experiences, they were found to not have synesthesia. This is the graph of scores showing consistency. In this graph, you can see that very few of the participants actually meet the consistency score criteria needed to be considered having synesthesia. So is synesthesia genetic? According to the research article, Familial Patterns and the Origins of Individual Differences in Synesthesia, 42% of synesthesia havers also have a family member with it, which is too high a percentage to be considered just a chance occurrence. Because of this, what is most likely inherited is a predisposition to synesthesia. Just because you inherit the predisposition does not mean that you will necessarily develop it. And you could develop synesthesia without anyone else in your family having it, but this is just much less common. This diagram shows examples of inherited synesthesia. The white shapes represent non-synesthesia havers, while the black shapes represent the family members who do have it. Circles represent female, and squares represent male. You may notice that synesthesia does appear to be more common in women, but as I stated earlier, this is just likely due to the differing levels of self-report between men and women. An interesting fact is that just because a parent has a certain form of synesthesia, for example, in family A, the mother marked by a 1 has taste to shape synesthesia. 2 of her daughters also inherited synesthesia, but they both have it in the form of linguistic color. This means that letters and words to them are a certain color. Because of these differences, this goes against the idea of a cultural transmission of synesthesia, where people believe that some groups of people might just generally associate some things with others. This is also supported by the evidence that some children do not inherit synesthesia, even though their parent has it. This concludes my presentation on synesthesia. Thank you for watching, and I hope you were able to learn something today.